Solution to exercise 1. Greatest common factor, 2, 2, 2. 3, no 3. X, no x. Greatest common factor, 3. Factor it out. Get a product of 6 times -7, -42, a sum of -11. Large number negative, small number positive. 3 times -14, -42. 3 times -14, -11. 3 minus 14, -11. The magic numbers are 3 and -14. 3 and -14. Factor out the 3x. Factor out the -7 to get 2x plus 1, which you can yank out. Don't forget copying this 2. And you're left with 2 times 2x plus 1 and 3x minus 7. Now, it wasn't so bad, was it? Example 2, greatest common factor, 2. Factor out the 2. You get a product of -432, namely 12 times -144. Correction. 6 times -72. These are smaller numbers. Can you imagine if you had not factored out the 2, your numbers would be bigger, would take you a lot longer to find. And again, the sum is -11. The magic numbers turn out to be 16 and -27. And when you factor this, your answer should be 2 times 3x plus 8 times 2x minus 9. Then in example 3, you have 24. 2 goes in here, 2 does not go in here, 3 goes in here, 3 does not go in here. There's no x here. Greatest common factor is 1. You've done your job. You look for the greatest common factor. So the product is 24 times 65, or 1,560. Ooh, those are large numbers. And the sum is -98. Well, we'll just play along. We have a calculator. It's not so difficult. So 3, 4, 5, 6, 10, 12, 15, 20. At 20, we get -98 for the sum and 1,560 for the product. So my magic numbers are -20, -78. Factor out 4x, factor out -13. Your product is 6x minus 5 times 4x minus 13. As I said, some people are good at looking at this and coming up with the right numbers immediately. Congratulations if you can do it. I can't, not when the numbers are big. But I have a sure way of doing it, okay? Factor completely 48x squared minus 216x plus 243. 2 goes in here, 2 goes in here, 2 does not go in here. 3 goes in here, 3 goes in here, 3 goes in here. 9 does not go in here. It's too bad. So greatest common factor 3. And then there should be a parenthesis here. And then I recognize something. This is a perfect square. This is a perfect square. Could this be the double product? Namely 2 times 4x times 9? It is. 9 times 8 is 72. Therefore, I have a perfect square here, and I get 3 times 4x minus 9 quantity squared. Now, wasn't it nice to recognize perfect squares? A squared plus or minus a double product 2ab plus b squared.